What is up, Math Mob? We are back at it again with another video talking about dilations on a coordinate plane. And our focus question today, how can you apply a dilation to a figure on a coordinate plane? So how is this different than the previous two lessons we did? Because we talked about dilations before. How is this one different? Go ahead and drop a comment below and let me know what you think. How is this one different? Okay, so before we move on, let's talk about this warm-up. Point C is the dilation of point B with a center of dilation A. So point C is a dilation of point B, and the center of dilation is A. So if I took a line and drew it straight out from A through B, here's my center of dilation, and I'm dilating B, so it ends up on C. What is the scale factor? The scale factor is S, so what could the scale factor be? So there's a couple ways of thinking about this. We could get a ruler and measure these distances. We could get a piece of paper and draw a line on it. I'm going to do that. I'm just going to draw a line. So there's the original point from A to B, and I'm just going to take that here and go to A to B again. So we have 1, 2, and a little more than 2, right? So it's going to be a little bit more than 2. Maybe it's not quite half, so it's more than 2, less than half. So we could say maybe it'd be 2.3, right? Maybe the scale factor would be 2.3. Okay, let's talk about our focus question and how this is different. Applying a dilation to a figure on a coordinate plane. Before, we were applying a dilation on a circle graph. And then after that, we applied a dilation without a circle graph. And now we're going to apply a dilation on a coordinate plane. Okay, this first part, it says, number 1, find the dilation of quadrilateral ABCD with center P and a scale factor of 2. So we have a center of dilation of P. So if we take, if we go to P and draw a line or a ray out from P through all these points, and I'm making them a little longer, I'm making them extra long because I don't know where my points are going to end up at this point. So on a coordinate plane, we could measure with our ruler, but on the coordinate plane we have these squares to help us count also. So we could go ahead and count if we go over 1 and up 2 for A. So if we go over 1 and up 2 for point A, if we do that scale factor of 2, we're going to do that twice, right? We're going to go over 1, up 2, over 1, up 2, and there's going to be our new point A prime. And we can do the same thing with B. We are going up 2 and over 1, 2, 3, 4, 5. So we go up 2 and over 1, 2, 3, 4, 5. So there's our next point. Same thing with C. Down 2, 2, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. So that's B prime, C prime. And then for this one, we go down 2 over 1, down 2 over 1. That's D prime. Okay, so let's see what that shape looks like. So now we have a rectangle that appears to be similar to the original. We used a scale factor of 2, and if you remember from 7th grade that when we make a scaled copy of a figure, the side lengths are whatever the length is times the scale factor. So if this side length is 1, 2, 3, 4, the corresponding side length right here, A prime to D prime, is going to be twice as long as AD. So if AD is 4, twice that distance is 8. So we should have 1, 2, 3, 4, 5, 6, 7, 8, and we do. And DC is 1, 2, 3, 4, 5, 6. So D prime to C prime should be twice that distance, would be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it is. Okay, number 2 says find the dilation of triangle QRS, this triangle here, with a center of T and a scale factor of 2. So now our scale factor, we're doing a scale factor of 2, so we already have our lines drawn through the points, our rays drawn through the points from our center of dilation. And we're going to use a scale factor of 2. So we're going from T to Q is up 1 and over 1, 2, 3. So we're going to do that twice. Up 1 over 3, up 1 over 3. It's going to be Q prime. And then for R, we're going down 1 and over 1, 2, 3, 4. And we're going to do that twice. Down 1 over 4, down 1 over 4. Down 1, 1, 2, 3, 4. And that would be R prime. And now S, we're going down 2 over 2, down 2 over 2. So that would be S prime. So now our new shape looks like this. Okay, and this appears to be twice the length. We go over 1, down 3. We go over 1, down 3, over 1, down 3. We did that 2 times to get this length. Okay, so let's do number 3. It says find the dilation of triangle QRS with a center T and a scale factor of 1/2. So I already know, since scale factor of 1/2, it's going to make a smaller. It's going to make a smaller triangle. So if I go up 1 over 3, I'm going to go half of that. Half of 1 and half of 3. So half of 1 is 1/2, and half of 3 is 1 1/2. So we'll just call that Q prime prime. And R, we're going down 1 and over 1, 2, 3, 4. So we're going to go down 1/2 and over 2. And that's going to be R. And then S, we're going down 2 over 2, and we want half of that, down 1 over 1. That's going to be S. So now our new shape looks like this. Okay, let's take some notes. How can you perform dilations on a square grid? Well, it gives us points to count, right? We can count squares to find new points, to find the dilated points. So for example, we could use the grid lines to count the distance. So from here to here we can go down 2 and over 4. So if we're going half the distance, we could cut these in half and go down 1. If we have a scale factor of 1/2, right? Down 1. And take these 4 and go half the distance of 4, which is 2. And we can go that far to get our new point. And the same can be true for coordinate grids with numbers. We could use the same method here, and we can add or divide, or we can multiply these lengths or divide these lengths with the coordinate grid or the coordinates. So let me show you an example of that. So on a coordinate grid, we can use the coordinate point numbers, the x and y values, to find the new points. So for example, if we are using A as the center of dilation, and we're going to be dilating B, and we want to dilate B, let's say 3, using a scale factor of 3 with the center A. So without drawing a line and without counting, I know that this coordinate point is 2 and 1, right? So this B is coordinate point 2 and 1. So if I make that new point, if I go over 2, up 1, I do that 3 times. So over 2, up 1, over 2, up 1, over 2, up 1. I could count, right? That's perfectly fine to find B prime. So what's the coordinate there? The coordinate there is 6 and 3. So what do we notice what happened here? This distance from the center of dilation to the point, the x value here was 2, and since we used a scale factor of 3, we multiply that x coordinate by 3. And the same thing for the y, right? We went 1 to 3, and the y coordinate was 1, so we multiply that by 3. And that distance here from the original point to the center was 1. So 1 times 3 is 3. Okay. And that's it. Okay, if you like this video, let me know using the comments below, and remember to like and subscribe and hit the little bell notification so you know when I drop a new video. Alright guys, see you next time. Bye.